Okay, guys, little change of pace here for probably from this point on for the rest of the year. I'm still in a position where I cannot move around, so it's going to be make it difficult for me to be up at the school teaching on the whiteboards. So we're going to give this a try. Hopefully you did well on the quiz today, sections 8.1 through 8.3 on sequences and series. This is a little unit here, a little lesson that's kind of a setup for our final 3 sections of the year. And in order to do it, we have to learn a new mathematical operation called factorial notation. Factorial is probably an operation you've never used before. Very rarely would you use it before you get to last semester of pre-calculus or maybe algebra 2 trig. But as you can see in the heading here, it is very important for both sum series and sequences that we've already covered. We'll backtrack and look at that, but then also very vital to section 8.4, binomial expansion, and probability, sections 8.5 and 8.6. It looks weird. It basically, a factorial is just a number followed by the exclamation point. And that doesn't mean just to say the number really loud. It actually has a mathematical purpose. And what it basically says is take that number and multiply it by every integer that's smaller than it down to 1. There is one special case that you have to kind of make an allowance for, and that's what 0 factorial is equal to 1. Now, that probably doesn't make a lot of sense. A lot of people would think 0 factorial is 0, but in order for a bunch of probability formulas to work properly, we have to make the exception that 0 factorial equals 1. So, just take you through a few examples. The easy one would be something like 2 factorial. And 2 factorial, you would just say, okay, start it with 2, multiply by 1, and obviously that's just equal to 2. Obviously pretty simple. If it's 5 factorial, it's 5 times 4 times 3 times 2 times 1. And that obviously brings up the kind of the make or break in terms of getting factorials right is, can you manually add these numbers together? Obviously you could run to a calculator, but we're going to do some without calculator, some with. So I would encourage you to think about how you want to multiply all these numbers together. For example, 5 times 2 is 10, and then 10 times 12 would be 120. You don't necessarily have to multiply it from left to right. You can use both the associative and the commutative properties to try to help you out here. But there's a lot of different ways here, but you could do 5 times 4 is 20. You could do 3 times 2 is 6. Obviously, the times 1 never has any effect on the answer. So you could say that 5 factorial is 120. And you can see that factorials grow pretty fast, even for a number like 7, which would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, what I would maybe do is think about multiplying 5 times 2 is 10. So maybe you could get a 42 for 7 times 6. You could do 5 times 2 is 10, and a 4 times 3 is 12. Again, there's a lot of different ways to do it, but I think sometimes getting a 10 in there makes some of the multiplication easier to do. So you could say it's 420 times 12. And then again, I know it's kind of a little bit of a pain in the butt, but you would try to go manual multiply that together, and obviously 10 times 420 is 4,200. If you add on another 840, you're going to get 5,040. Okay. Again, if you have to go off to the side and do long multiplication, there's nothing wrong with that. Okay, so as I said, factorials can be can turn into be some very large numbers. Just 7 factorial is already up to 5,040. Again, when you're working without a calculator, look for easy ways to multiply the numbers together. Sometimes you have 3, 4, 5, 6, 7, 8, 9 numbers to multiply together. Pick pairs that are easy for you to multiply together, and then do the complicated work at the very end. A lot of our work will be with factorials being involved in fractions. Most of the formulas that come up with binomial expansion and with probability, you're going to see factorials in fractions. Okay, and what's going to happen is a lot of factors are going to cancel out. So I'm going to do this first one two different ways. I'll show you the long way to do it and then show you maybe how you should maybe be a little ahead of the game and kind of predict which factors are going to cancel out. So this first one you can see is 10 factorial. So that would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's over 8 factorial, which is obviously 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you can also see a 2 factorial in there. So that would just be 2 times 1. So clearly a lot of things cancel. You can see that that the 8s would cancel, the 7s would cancel, the 6s, the 5s, the 4s, the 3s, the 2s, and the 1s, obviously. And then you might even see that, okay, I got 10 times 9 over 2 times 1, so 10, 90 over 2, or you could even do 2 into the 10 and make it 5, and then you can see the answer is pretty easy, just 45. Okay, now that looked like a really tough problem to begin with, but so much canceled out that it was actually easier to do than something as simple as 7 factorial. Now what I might encourage you to do is maybe look at this problem and instead of writing it all out long ways, you get to the point where you kind of recognize 10 factorial and pick the bigger of the 2 factors down below and say, okay, well, let me see how much of 10 factorial would cancel out with 8 factorial. And if you do a little bit of a prediction, you can see, oh, that's clearly going to be 10 times 9. And then 8, 7, 6, 5, 4, 3, 2, 1 is all going to cancel out. So you don't need to write all that out and then show that it's canceling. It might be better that you kind of predict that's what's going to cancel out. And you would have been just left with this problem. Again, you can finish that one off pretty easily and just say it's 45. Now, the way I can test you on factorial when I'm asking you to do it without a calculator, even though I don't have the ability to watch you when you're doing it, is to put variables into the problem. And again, the principles of what you did over here would be involved here. So n plus 2 factorial over n factorial, you would say, okay, well, that's n plus 2 times n plus 1 times n minus 1, all the way down to 3 times 2 times 1. Well, n factorial in the denominator is obviously n times n minus 1 times blah, 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 all the way down to 3 times 2 times 1. So kind of like how the 8 and everything below canceled out over here, you could say that, well, this n would cancel, this n minus 1 would cancel, and so would everything in between all the way down to the 3, 2, and the 1. And all you'd be left with is n plus 2 times n plus 1, which of course is n squared plus 3n plus 2. And again, you'd always want to simplify it, not leave it in factored form. So if we were in class, I'd maybe give you another example of a number 4 or a number 5 and have you give it a shot. But since we don't have that ability, I'll just kind of do one more problem with you. And of course, give you a bunch of homework to see if you got it. Okay, so here's another one, n plus 1 factorial over n minus 1 factorial, so that would be n plus 1 times n minus 1 times blah, 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 3, 2, 1. You could say that's over n minus 1 factorial, n minus 2, blah, 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 3, 2, 1. And again, you would see that everything from n minus 1 down would cancel out. And you'd be left with n plus 1 times n, which of course is n squared plus n. So again, just start with whatever the number is that's originally given in the factorial, and then just start multiplying by one integer less than that until you get down to 1. And again, if it's in a fraction format, you're going to see a lot of things canceling out. Okay. So the last thing to do, and it's a really short assignment for you to work on, is just how do you do this on your calculator? Obviously, the calculator has the ability to do factorial just like it does any other mathematical operation. It's not going to be a button that's readily visible on the calculator. What you're going to have to do is go to the math menu. You're going to scroll across to the right up top. You will see different menu options. One of the menu options is PRB. And that stands for probability. And underneath that menu, you'll see a bunch of features that we'll be using when we do 8.5 and 8.6. But one of them is obviously the exclamation point, which is, again, for factorial. And what you're basically going to want to do is just activate that by hitting option 4, and then go through and actually do the factorial. So let me grab my calculator. Sorry about that. It takes me a little longer to get around nowadays. But if we just practice together, obviously you can't see what I'm doing here, but calculator in the on position, you would just hit the button math, hit the right arrow key 1, 2, 3 times to activate probability. You could hit option 4, and you could say, all right, that's where I'm going to do factorials. Now, one thing you have to do is you have to enter the number prior to doing that so that the calculator knows which factorial you want to do. So if I'm doing number 1, I would enter the number 9 first. Math, scroll over to probability, choose option 4, and then it appears on your screen exactly how you would like it. Hit enter, and for this first one, you can see how it gets big really quick. I got 362,880. Okay, again, that's just 9 factorial, so you can see these things explode quickly. This explodes even bigger than exponential if you want to kind of compare it to something. So again, just to practice, 12 factorial, put in 12, hit math, scroll to the right to probability, choose option 4, hit enter, and this one's huge, 479,001, 600. So what is that? That's up in the 479 million. Okay, I'll let you practice with 20 factorial, and then I pose a question here for you, and you can just do a little experiment, a little playing with your calculator, practice with it. What's the biggest? Okay, what number does your calculator? It might depend on which calculator you have. Newer versions might be able to go a little higher than others, but you'll find a point where you just can't, calculator just gives up. The numbers get too big and it doesn't want to do it. Okay, while you're doing that, I'll get you the answer for the third one. And obviously it goes right to scientific notation, so you would say something like 2.4329 times 10 to the 18th. So that means there's, move the decimal point 18 times, and you're talking about a pretty large number. Okay, hopefully that gets you set. This is just a really quick, maybe 10-question homework assignment to kind of get ready for the next couple sections, and we had to do that because this mathematical operation of factorial is going to be involved in all that. Okay, thank you, and we'll talk to you soon.